Hello everyone, welcome back to another episode of Coding Challenges. Here's vanAmsen. Today we have a thrilling topic to discuss and solve. Solving the last day where you can still cross. So we will try to tackle this problem using disjoint set union approach in Python. So this problem challenges us to find the last day on which it's possible to walk from the top to the bottom of the binary matrix without encountering any flooded cell. So let's dive in and explore the solution together. So to tackle this problem, we start by implementing the DSU data structure. So DSU stands for Disjoint Set Union, also known as the union field data structure. It helps us efficiently manage sets of elements and perform operations like finding the respective member of a set and merging sets as well. So the DSU class has three main methods which we will implement. So init, find, and union. And in init union method, we initialize our DSU object with the size of the grid plus 2 extra nodes for the top and bottom rows. So let's implement it and I will explain everything right away. So class DSU will be define init, self, and self root will be list of range and self size 1 multiplied by n and defined find self of x. So if self root x not x, then self root will be self find self root x and return self root x and define union self x y and root will be x self find x and root y will be self find y. So if root x equal root y, then return, and if size root x greater than self of size root y, then root x root y will be root y and root x. So swapping the places, and self root x will be root y and self of root y plus self size root x. So this is our implementation. So yeah, here is intention. Okay, all good. So the find method uses path compression to find the root of the element in the set. So it recursively traverses the parent pointer until it reaches the root, optimizing the future find operation. And the union method merges two sets by connecting their respective roots, and we also keep track of the size of each set to perform a weighted union, which help maintain a balanced DSA structure. So now let's move on to the solution class. So yeah, we have, so here's solution class, and in solution class, we will implement our main logic. So yeah, I think I can turn it left. So we start by creating a DSU object and a grid that represent the matrix. Initially, all cells are considered land. So we define the 4 candidates direction and iterate over the cell array in reverse order. So for each cell, we will mark it as a water in the grid and calculate its index using row and column information. So next we will iterate over the neighboring cells in all 4 directions. And if we encounter a land cell, we connect the current cell index with the neighbor index using a DSU union method. And additionally, if a current cell is in the top row, we can connect it to the virtual top node in the DSU. So similarly, if it's in the bottom row, we can connect it to the virtual bottom node. So let's implement it, and I will explain everything right away. So first, DSU will be DSU row times column plus 2 DSU object with the size of the grid plus 2 for top and bottom. So grid will be 1 times column for range in row, and this initialize the grid with all land cell. So directions will be 0, 1, 0, 1, 1, 0, minus 1, and define the 4 coordinate directions. So for I in range of length of cell, minus 1, minus 1, minus 1. So RC will be cells I0 minus 1 and cells I1 minus 1. So grid RC will be 0. So we set the cell as water 0. So finally, index 1, R times column plus C plus 1. So calculate the index of the cell. So for direction, DC in directions, so row and columns, new row, new column will be R plus DR and C plus DC. And index 2 will be new R times column plus new C plus 1. And if 0, so new R will be row and 0, less than new column, less than column, and grid new R new C equal 0. So DSU union will be index to connect the current cell with its neighbor. So land, and if R 0, DSU union index connect the top row cell with the virtual top node. And finally, if R equals row minus 1, so DSU union row time column plus 1, index 1, connect bottom row cell with virtual bottom node. So if DSU find 0 equals DSU find row times column plus 1, return I if top and bottom are connected, return the current day. So return minus 1. So if no path is found, we return minus 1. So this is our implementation. Hopefully it will work, so we can check if it's working for those sample case. So small grid and output is 2. So yes, as you can see, so for this visual representation of the land and water, so the above image this depict the matrix change each day and starting from day 0, the last day where it is possible to cross from top to the bottom is day 2. So yes. And now after connecting the cells, we check if the top and bottom nodes in DSU algorithm are connected. And if they are, it means that a path from the top to the bottom, and we return the current date day as a result. And if we complete the iteration without finding any path, so we return -1 to indicate that it's not possible to cross from top to the bottom. So, and there we have it. So let's see if it's working for unseen test cases as well. So I'm running submission and hopefully it will pass. So yeah, it's passed and you have been awarded DCC June 2023. So first time. So consistency is key. See you next month. So yeah, it's probably because I have solved 30-day challenge. So today is day 32, but I have completed also all days, challenges daily for 30 days. So really nice. And our implementation beat 70% with respect to runtime, so it's really good, and also 90% with respect to memory. So as you can see, it's quite memory efficient. And yeah, there you have it. We have successfully solved last day where you can still cross. So problem using a DSU approach, and this algorithm is both time efficient and elegant, and utilizing the power of DSU data structure to efficiently determine the last day of crossing. So I hope you enjoyed today's episode and found it enlightening. And DSU is a versatile data structure with various applications, and it's always fascinating to explore how it can be employed to solve challenging problems like this one. And as always, don't forget to subscribe to vanAmsen coding challenges, and for more exciting episodes on algorithm, data structure, problem solving techniques. Until next time, happy coding, stay motivated. See you next time.